Hey, today's trek into DIY tech is going to be on CAD. And it's not going to be the normal, what's the least expensive CAD or what's the best CAD to use. We're actually going to look at you as a maker. Why should you even bother using CAD? And if you're a hobbyist, is it, what do you need CAD for? Right? So that's what we're going to look at in this one. All right, if you're seeing a glow on this side of my face, please try to ignore it. We're still working on the lab, so there's no shade on the window over here. So I'm just going to be shiny on that side. And without the AC on, there's no insulation, so I'm kind of shiny on the top of my head. But anyway, that's not what we're here for. So I'm going to show you something that may help you get a picture of why I started using CAD. I've been using CAD for a long time. I used it for work, and so for many years, and it was like the industry standard was SolidWorks. So I'm a SolidWorks guy. I've used other CAD in the course of, running the makerspace and things like that. But mainly, I've used SolidWorks. For various reasons. Everybody has a different CAD that's their favorite and different reasons for using it. Like my mom used to say, cada cabeza es un mundo. That just means, for every mind out there, or free thinking brain, there are reasons for them doing things. And so you're not going to find one solution that makes everybody happy or works for everybody. So this is not about that. This is about, should you even pick the tool up or not? And one of the main reasons is I'm going to show you a project. I'm just going to reach down here and grab it. So I'm going to show you a project that was the subject of one of my other videos. And so this is the Aquatic Rover. Purpose of this thing is it's basically a robot. So down here it has camera mount for an underwater camera, and it has space for sensors, right? So pick up water temperatures, turbidity, the whole range, pH, things like that, right? And so this guy will go to spots repeatedly, right? So you go to a GPS location, stop there, take the readings, record them, and bring them back. So cool, right? So whatever, right? It's a one and done. You think to yourself, right? So why would you even need CAD to do something like this? So now the thing becomes, recently we had a storm, right? So you see these thrusters, right? Beautiful thrusters, right? We just recently had a tropical storm out here, and a lot of debris got pushed up onto the shore out back in the canal. And I thought to myself, if I run this thing, when it comes back or going on the way out, there's stuff going to be just, those thrusters are going to be done, right? So guess what? I decided to change the design. But now I'm looking at this thing and I'm going like, ooh, limited budget. I just don't want to start throwing material together, which is how I did the initial design. Just don't want to start throwing material on this thing and try a bunch of different iterations and not even get the measurements right out of the box, right? So that was one thing. So then, just long story short, right, I thought to myself, yeah, I've seen the designs online for, Colin Furze had one, and Mr. Bruton had a design that was basically a screw. You'll see it later. I'm going to create a different video showing how that part goes together. But so envisioning these fitting on there, but imagine if I had a CAD model, I'd be able to just go on there and just do that, right? Switch the parts out and we'll have it. So now what I'm going to do is I'm going to take this part, and I'm going to show you how quick and easy it is to recreate this part to build up a model for yourself. And now I'm sure you can probably find this part online somewhere, but I'm just going to go through the process to show you how easy it would be to recreate this part so that you can recreate all the other parts and put together a model that you can then experiment with digitally and not spend any money on parts or anything before you can, come up with a proof of concept that you want to try out. Of course, the final, right? You got to put it together and send it out in the wild and have it do its thing. But initially, right, you can do all your testing and everything on the computer and see if it's even going to fit together the way you think it. All right, guys, what I'm going to tell you now is, as you can see, I'm using SolidWorks Maker, right? So there are various and numbered versions of CAD out there. Again, they haven't sponsored this or given me any money to show you this or anything like that. This is just the one that I use because I just happen to like SolidWorks. So they haven't paid for this in any way. This is not a commercial. I'm just going to show you real quick what I do to get parts in there to have a model that I can play around with. And so the first thing you want to do is so I've got my SolidWorks opened up. I've already set up a file, so I'm just going to go ahead and open that real quick. Let's see, recents, and I'll open that up. And so good to have a lot of memory because this is memory intensive, especially when you start getting to large models. But this is the thing. So Onshape, which also has not given me any money or sponsored this, has a free student license and teacher license. As of the recording of this video, I think that's correct. SolidWorks Maker license is a yearly or monthly. So I've purchased myself the yearly, and it's going pretty well so far. I like it. Again, I'm old SolidWorks user, so anyway, we'll start with a plane. And so since we're saying front, I'll call this the front. And first thing to do, and again, so you don't have to go to college or take courses for this, or if you're just going to use it as a hobbyist, I would recommend though, and they're probably going to want you to have certifications if you're going to use this for work, of course, because it's although you don't need to know best practices and things like that to use this as a hobbyist, in the industry, depending on where you go, it's you're going to need to know best practices and a whole bunch of other things to make this work in that scenario. But in this case, we're just making a part for our hobby project. So first thing you do is you get the measurements on there. It's like 1.1, 1.1. So I'm going to start with a construction, just a little construction sketch on here. So you just go and sketch. I'm going to grab myself a square, and I'm going to pull it out to close to the size or the aspect ratio. Boop, just like that. I'm going to select for construction here, so you see it makes it a dotted line. So I'm going to use that to give myself some constraints when I'm making the profile, and then I'm going to make a profile and just rotate it around the center line, right? So as a matter of fact, just for clarity's sake, I'm going to add a center line here. And again, this is not a CAD class. I'm just showing you how easy it is really to, and if you have hotkeys like I just did, you have to terminate the lines and everything. But again, this is not a this is not a class. So We're just going to do that. And then, so what you want is you want half of the profile. So if you chop this in this plane like this, if you could take this and cut it down this way, you would see that this makes kind of a U shape. We want half of that U, so we're going to make half of that U in the program, and then we're going to rotate it about the center axis to get a three-dimensional object out of that. So that's what I'm going to do now. I'm going to draw half of this in the program, and we'll have a profile to rotate against. So what I'm going to do is I'm going to set some lines down, and so now you don't really have to initially put any numbers down, because so watch what happens here. We said this was 1.1, so we put 1.1 in there. Boom, and you see what happens. Now it will start with giving it dimensions according to the proportions. Once you put the first dimension in there, it'll change everything else to have dimensions based on the proportions that are already in the drawing. So now we've got these two lines here. I'm going to give myself an arc here to kind of draw against. And there's various ways to do this, right? So there's 1,000,001 ways to do this, but I'm just going to do it this way to well, I'm going to use the center. Or how should I say, a tangent arc, just to make it easy on myself. So now we're gonna set up some other lines here, and then I'm gonna show you how this is gonna work in a second. We're gonna create another arc here. So now you see that these two lines you can select them and make them parallel to each other. I selected so we select these two lines, and now we can make them or they're curves. Let's make these concentric, and so you get that. And now we're going to define the thickness of the wall, right? So we're going to go ahead and dimension the thickness of the wall here, and let's take the measurement. Let's take the measurement and a spot where there's no flash, and it's telling me 0.13. All right, so 0.13, 0.13, boom. And then what we're going to do also is we're going to make this line so that we have the same thickness. I'm kind of doing it rough here, just to, and I selected again the point. Okay, so we're going to make this line equal to this line, and then we'll see that the thickness also make those equal, and you'll see, boom. Now we have the profile that we want. For me, I would add more detail into here to give it, additional the additional features that are in the actual part. You can see a rim down there that stops the actual the pipe that goes in there from bottoming out on the inside. It gives it more purchase when you put the glue in there. But we're not going to mess with that. We can also good idea to define this. So we could do it, actually do it on the outside. But you see there, you can add the radius. Now we're going to leave it at that, because that's pretty close to where we are. There are ways to do this to get the exact measurement, but I'm going to do this.
if you wanted to, you could put this. You could put this flat against something, and there are ways and ways to measure this. But if you just wanted to do it quick, you just want to do this quick and get yourself a measurement. You can do this, and then as you go in the program, you can actually have this as the dimension, right? And so you plug that number in and it'll automatically change the radius. So if I do it now, it's going to be a conflicting thing because I have two different dimensions trying to drive. So what I can do is, you see how it'll throw this up, and you can leave this dimension driving or make this dimension driven. If you make this dimension driven, what's going to happen is the other dimension will just be for reference. And so I'm going to leave this dimension driven, and now the other dimension is just for reference. This is the one that's going to change. That's going to change how, or the radius is going to change how this one changes. So if I change, because this one is driven, if I change the radius, now this measurement will change, and I've only got two decimal points there, so you're not gonna see a change at. So let's see. Let's say this, and you'll see there that that dimension has changed. All right, so we'll leave it there. And now we're going to show you how this flat piece turns into a three-dimensional part. So we're going to go to features, and we're going to do a revolved, because we're going to revolve this around this central point. So now you see why I put this this line here, right? So for construction, but we can use it as the point that it revolves around. So axis of revolution, we select that guy, and now you can see it gives you a nice nice little preview of what the part is going to look like. And so we say yes, okay, do it, boom, there you go. And now you have something that looks like that cabin. Of course, you can refine this. You can put a fillet on the edge and make it look a lot closer to the actual part and everything. So there you go. But anyway, that's the basis of the whole thing, and that's just that easy. Just that easy. And so if you want to make it look even closer, let's grab some plastic here, and this is pretty high gloss. This is high gloss plastic. We use the high gloss white plastic. There we go. Drop that on there, and then we'll do the entire part. Boom. And there you go. Yeah, I've got my camera set a little wonky on there for rendering, but there you go. There's the part, and so on and so forth. And again, my purpose with this channel is we're not giving the expert or the master class on here. I'm just doing these things so that you can see, hey, it's not such an insurmountable. Is that correct? Unsurmountable or insurmountable? It's not a hill that you can't climb up, right? You can do it. And hey, the reason to do it again would be it helps you go through different iterations in your project without having to spend the money in parts, or sometimes it saves you a lot of time, right? You can make some quick changes in your model and see if everything's even gonna fit, right? Let alone work. So, hey, again, I appreciate the time you spend with me. If you like the video, like and subscribe, and tell everybody about these videos, and let's see if we can continue making them. We'll see you in the next video.
CAD is great. CAD is wonderful. CAD, 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 CAD. You should use CAD.